Well, greetings, Mr. Colazar's class. Continuing with our periodic table trends, we're now going to look at ionization energy. So now ionization energy is going to be the energy required to remove an electron from an atom. Now we think about ionization, ions are first part. So what we're looking at is energy required to remove an ion from the atom. So to remove that energy, or remove an electron, so if our electron's moving around the nucleus, it's being pulled towards the nucleus, so there's an attractive force there. So how much energy does it take to actually move that electron away or to remove it from the nucleus? So there's some amount of energy needed to make that ion, and now this would be positive, and we'd have lost that electron to somewhere else. So ionization, that amount of energy. Now, our first trend is as we go down the periodic table, from group to or down the period, electron shielding makes it easier to remove the electron. So when we look into this, our nucleus and then each energy level around it, the further away those atoms or the electrons get, the further away that they are from the nucleus, the less attractive force there is. These energy levels with their negative charges in there shield the attraction of the nucleus to those outer electrons. So as you go down from period 1 to 2 to 3, 4, 5, 6, 7, the more energy levels you have, the more they're shielding or easier for them to be pulled away. Now our other trend is, as you go across the period, what we're looking at here is that we're going to increase, or it's going to be more difficult to pull those electrons away. So as we go across the group, the nuclear charge, known as our 4 Ps, the proton pulling power, is going to make it harder and harder for those electrons to be actually pulled away. So it's going to be very difficult to pull the electrons away once we're over on this side, easier to pull away or on this side. So easy versus difficult. So those are our trends for the ionization, and that's for the first ionization. And what we mean by first ionization, it's possible to remove more than one electron while we're going. Each electron is removed one at a time. So we call our first ionization energy the energy required to remove the first electron from an atom. So how much energy does that take? And then from there, then there's the second energy, the third, the fourth ionization energy required to remove a second, a third, or fourth or electron from the atom. More energy is required or needed each time we do this. So the more electrons you pull, it becomes more difficult because then we have more protons each time pulling on the electrons that are left. So there's more pulling after you remove each electron. Now, each electron more difficult to remove, or more energy is needed to do that from an atom because of the proton pulling power. So as we go across that period, more pulling power. Noble gases, very difficult to remove because they're at that full outer stable energy level. So if we jump back, these ones going to be easy, or easy to remove. I guess easier might be a better way to say it. Easier to remove. And these ones are going to be more difficult to remove. So we kind of have this trend as you go across and as you go down, easier to remove down here, harder to remove over here. So that ends our ionization energy information.